Guys, I'm using a place value chart that looks very similar to the place value chart that we've been using in your homework. I put my little houses up above these like we did in our notebook so that it matches the place value I have. So I know that this is the millions. I know that these 3,000, 10,000, 100,000, see it goes ones, tens, hundreds, all go in the thousands. I got ones, tens, hundreds, they all go in the hundred. Then I have my and, or my decimal point, and then I know it goes tens, hundreds, and that's in the hundredths. And then I have thousands, and it goes in the thousands. So I know that when I read this, I can say 6 million, because that's that house, 6 million, comma, 290,000, comma, 107, and 403 thousandths. So that is my number when I say it. When I say it like that, it helps me write it in word form. However, today we're talking about the different, we have all different digits in here, but each digit has a different value. So in this case, this 0 is the same digit as this 0. However, they are not the same value. So that's what we're looking at. They are the same digit, they are not the same value. This digit is the same as this, is the same as this. They are all the same digits. They are not the same values. So let's look at the zeros right now because it's easier to think about when they're the same digit. Okay? So we have this 0 to this 0, and if I go this way, you can see that that's this to here is times 10. To here is times 10. To here is times 10. So when this digit moves to here, it's multiplied by 10. When that digit is moved to here, it's multiplied by another 10. If I move the digit again to here, to the tens place, it's multiplied by another 10. So I jumped 1, 2, 3 times, which means I need 3 tens. So this is 10 times 10 times 10, which means the value of this in the tens spot is 1, and then I've got 3 zeros, 1, 2, 3. This value is 1,000 times bigger than this value. It's 1,000 times bigger than that value. Okay? And again, I can figure out how, let's take this guy right out of here. Let's figure out how much this value is compared to this value. So I add another times 10 and one more times 10. So I now have 1, 2, 3, 4, 5 jumps. I now have 5 jumps, which would mean I have 5 tens. 10 times 10 times 10 times 10 times 10. I have 5 jumps right there. 10 times 10 times 10, 5 times. So I put the 1, and I have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros, which means that the value of this 0 in the thousands place is 100,000 times bigger than the 0 that's in the hundredths place. So I count my jumps. This value is 100,000 times bigger than this value. Okay? The digit is the same, the value is different. So, I know that it gets confusing when you have different digits, but it doesn't change the difference in the value of where it's sitting. So even if I were to pick this 0 and I wanted to know how much this 9, how much bigger this 9 is in value than that 0 down there, all I need to do is figure out how many jumps. So I go 1, 2, 3, 4, 5, 6 jumps, which means that I need 6 tens. 10 times 10 times 10, there's 3, times 10 times 10 times 10. There is 6. I can multiply them all out, or I can do it the easy way. So you can sit there and multiply them all out, and that is fine. I can put a 1 down here and count my zeros. 1, 2, 3, 4, 5, 6. Should match how many jumps you made. Should match how many zeros are down here. 1, 2, 3, 4, 5, 6. So this value here, this value here is 1,000,000 times bigger than that number down there. He is 1,000,000 times bigger than that 0 that's down in the hundredths place. So as we jump, that means that you need to count. You need to count and jump. I will do one more, just for the sake of doing one more. So I'm going to change off my 0 here. I'm going to look at the ones place. And I want to know how much bigger this millions is, the 6 that's in the millions place is than the 7 that's in the ones. I want to know the difference in values. So the value goes from here. We go 1, that's times 10. 2, that's times 10. 3, that's times 10. 4, 5, 6. Each one of those is a 10 times 10. So we said 6 jumps. 1, 2, always count to make sure. 1, 2, 3, 4, 5, 6. And we put 6 tens. 1, 2, 3, 4, 5, 6. So now I have my 6 tens, my 6 jumps. This millions, this digit that's in the millions is going to be that much bigger. So I put my 1 down and I count my zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put my commas in. This 6 is 1,000,000 times bigger than that digit down there. Okay? So make sure you're counting your tens. Do not count them and say it's 6 times 10. That is not the same, because 6 times 10 is 60, and we did 6 tens. 6 tens, 6 groups of 10. So it actually ends up being 1,000,000. 60 is a big difference times 1,000,000. Okay, so this is wrong. We don't want to do this. This is the way we do it. 6 of these. 6 of these. Okay?